In our rapidly changing world of migration, mobility, and globalization, society has become increasingly complex. Now, add to that the exponential development of all forms of technology, then work using these technologies in relation to society becomes extremely challenging. This is what engineering practitioners do. They work at the interface of science, technology, society, and nature. How they are trained to do their work in engineering education institutions is governed for many countries by international accords and national professional bodies. Now, these accords and bodies specify through standards the knowledge, skills, practices, and values required to be eligible to become a professional. Despite the standardization and detailed specifications and accreditation processes, global surveys of employers confirm consistent skills gaps and shortages to tackle today's complex challenges. Now, the annual skills reports routinely list the top 10 requirements for graduates in general, and sometimes these actually look like lists of ingredients and recipes to make a cake. The problem is the gap between the specifications, the list of ingredients and steps, and the actual cake in context at a birthday party. There are increasingly complex nuances in the space of contextual practice. Now, the argument in this paper is that these things that we call graduate attributes are lists of different kinds of knowledge, skills, practices, and values. And the lists, as well as the shifting priorities of the market out there, are not helping educators to deliver the holistic graduates industry so desperately requires. So the focus for this presentation is, what do we mean when we talk about graduate attributes? Who is we? Higher education, the International Engineering Alliance, academics, employers? Well, we take a look at a range of these stakeholders over a 30-year period to try to understand what is meant by a graduate attribute and how the focus has shifted over time. How should we be approaching the development of these graduate attributes so as to better bridge the gap between what we do in education and what employers keep asking for? We started by looking at the 4 versions of the International Engineering Alliance competency profiles since 2005. Essentially, all the versions have retained a core knowledge profile, but over time we see the graduate attribute profile referring more and more explicitly to social attributes, such as protection of society and taking account of stakeholder views. The latest version refers to diversity and inclusion from ethical and teamwork perspectives, suggesting increased global awareness of pervasive inequalities. Our next step was to take a look at formal literature. And what we see over the 30-year period in all these lists of what are the top 10 attributes and top 10 skills and top 10 practices is a shift from particular kinds of knowledge and technical skills to generic competencies. In the early 2000s, we see an attempt to start distinguishing between generic skills and positive values and attitudes. The next shift is a clear focus on employability and technological competencies. We see organizations talking about flexibility, adaptability. Now, in all these shifts, we see the constant production of these top 10 lists. And academics and engineering faculties are constantly trying to play catch up and make sense of how to enable holistic development. So we went back to the beginning. The term graduate attributes was coined by an Australian named Simon Barry, and he proposed a relational way of thinking about what we want of our graduates. He proposed a threefold stance. Our graduates need to develop a stance towards knowledge, towards themselves, and the world. Now, the puzzle pieces demonstrate the relationship between these 3 elements. For example, to conduct research or inquiry into kinds of knowledge means accessing, interpreting information literacy, which is dependent on personal, self-regulated and independent practices. Using this knowledge and accessing this knowledge happens in relation to the world. It's orientated from something and towards something. Now, with this relational model as our framing, we then took a look at all our graduate attribute resources, an extensive literature database, higher education institutional websites, industry reports, and we were looking for sources that used the term graduate attribute that were relevant to engineering education. We collated the lists of these attributes onto a large spreadsheet and separated into the 4 periods, aligned to the 4 IEA graduate competency profile versions. And collaboratively, we analyzed these lists and coded them according to the 3 elements: knowledge, self, the world. Now, here is an example of sample literature across the 4 IEA periods. Look at how the word teamwork shifts in position over time. This is the kind of thing we were looking for. When we look at industry, employer documents, we notice very different kinds of attributes starting to enter the discourse. Things like empathy and resilience. Now, using this strategy, we quantified all the references across the different sources against the Sydney model: scholarship, lifelong learning, and global citizenship. However, we separated all the references to communication because we believe this practice is dependent on a synergy between drawing on a form of knowledge, having the confidence to express oneself, and understanding the context, the world of the act of communication. And what we see from this analysis is an increasing focus over time on an orientation to self, and the descriptors become more and more nuanced and refer to innate pre-existing qualities. So this begs the question: how can engineering educators elicit or support the development of such qualities when the predominant engineering education documentation consistently reduces these to skills checklists? We suggest the qualities desired by employers in complex multi-systems contexts requires a synergistic relationship between the Sydney model components. Having empathy, for example, requires awareness of self, other, and context. To demonstrate this relies on communication, whether verbal, physical, technical, or professional. Effective communication requires access to the relevant forms of knowledge and their associated practices, whether that be to write out an equation, construct a user manual, take stakeholder meeting notes, code a program. Now, one approach to developing relational GAs is project-based learning, for example. Engaging in a real-world problem as a team requires access to and meaningful engagement with forms of information as part of research and inquiry. It means developing ethical practices in relation to self, other, and the discipline. The bottom line is that our current standardized GA lists are not helpful in enabling educators to meet employer needs. Rather than reinventing the wheel, innovative approaches need to be developed in adopting a holistic and relational approach to developing graduate attributes. Thank you very much.